This is a video to accompany the kinetics experiment from Chem 129 at Geneseo. As you start out, I would encourage you to review the pre-lab slides, which are up on Brightspace. In particular, I think it has some info about some of the calculations that you'll do outside of lab that are going to be helpful to you. Reminder that one of the first things you have to do is calculate an extinction coefficient, epsilon, so that you can convert the measured absorbance to a concentration. This slide will walk you through that. After you do that, you're going to import some data into Excel and do some graphical analysis. Okay? And that's what I'm going to spend most of this video talking about. I am working on a PC using Excel. If you're working on a different system, a Mac, some of these instructions might be slightly different. If you're using a different program like Google Sheets, they'll also be different. I would really encourage you to use Excel. I think it's a really good program. Okay, I've copied some sample data onto my desktop. Here it is. If you just double click your data and try and open it, you'll see that it opens usually in a program called Notepad. This won't work. You need it in Excel. The easiest way to do that is to open an Excel worksheet. Go to File, Open. I'm going to browse to my file location. So mine is on my desktop. There's my desktop. You need to make sure that this setting right here says all files. Sometimes it defaults to just Excel files. Right? But if it's at all files, you should be able to find your sample data someplace. Okay, here it is. Double click it. It opens an import wizard. You can step through this, but the short version is all of the default settings will work. So you could also just click finish. And here you go. It has now imported your data into Excel. You can see I have time in the X column. I have the absorbance at 530 in the Y column B. This is run 1. I scroll down a little bit. Here's run 2. Run 3 is after this. First thing I'm going to do is reorganize my data. And so in order to do that, you can go through and copy paste or cut paste your data. You could imagine going through and sort of selecting all of it bit by bit, but I'm going to show you one quick trick. If you hold down Shift when you are using Excel, it will pick all values in between. So if you notice, I started by selecting some cells at the top of run 2. I'm now holding down Shift, and if I click this 600, it automatically picks all of them. Okay, so it'll save you some time. I'm going to Control X, cut it. Or I can do it this way, cut it. Okay. And then I'm just going to paste it over here someplace. So that was Control V, paste. I'm going to go down and find run 3 and do the same thing. Okay. Again, I pick some data at the start. I scroll to the very bottom of the data set. Hold down Shift and select the end, and it selects everything in between. Cut and paste it. And there we go. First thing I'm going to encourage you to do is to plot your data. And so you should be relatively familiar with this. But the first thing you're going to do is select your XY columns that you want to plot. Insert. Okay, and I'm going to pick a scatter plot. I'm going to move my chart so that I can put it back up at the top and look at my data. And make sure this looks right. You'll note that time is on the x-axis, so it goes from 0 to 600 seconds. The y-axis is the absorbance. That's right. This all looks relatively good. However, if you're paying close attention, you may notice that there's a small problem. Okay, and that's here. This is suggesting that at the end of the experiment, my data set is ending at an absorbance of 0.1. However, if you remember the actual appearance of your solutions, they were clear. We would expect them to not be absorbing any light. And the reason that this isn't going to 0 is because the background correction in the spectrometer was imperfect. It turns out that the cuvette can wiggle a little bit in the holder, and if it isn't positioned exactly the same, you'll get a non-zero correction. And so what I'm going to encourage you to do is to adjust your absorbance values so that the final value has a numerical value of 0.05. In other words, you're going to subtract an offset from every single value in here so that it goes to 0. If I look at mine, I have a final value of 0.104. I can see that here. And if I want the final value to be 0.05, that means I'm going to subtract about 0.05 from each of these. So to perform a mathematical operation in Excel, you always start with equals. I'm going to click the cell that I want to subtract from and then write minus 0.05. The value that you subtract in your offset might be different. It might be 0.2. It might be negative, in which case you're actually going to add something, right? Remember, subtracting a negative is equivalent to adding. Or it might be that your data just goes to 0, in which case you don't need to manipulate it at all. But once you've done that, this is where Excel is really nice. It can iterate this formula automatically for you. So if you go to the lower right-hand corner of the box where you just entered the formula, click and drag, it will start to fill it in. Okay. So what this has done is copied that formula to the next cell. And you'll see that this is subtracting a value of 0.05 from each one. One other little trick, rather than click and drag, you can also double click. So if I go to the lower right and double click, it will automatically fill in the cell values for all of the cells in the column. So that'll save you some time. I want to plot this new data set, and I'm just going to label this. This is my corrected absorbance, A core. This was A. Okay. A shortcut if you want to plot that data. If I click on the data set, you can see that it's highlighted these two columns. It's telling me those are the two it's plotting. And if I go to the edge of this column so that I get this particular cross, I click and drag, it automatically plots that new data set. So you can see now that this absorbance at the end of the experiment has changed. It's about 0.05, which is where I left it, where I wanted it to be. I've correctly accounted for the background subtraction. The next thing that you're going to calculate is the concentration. Okay, so you're going to calculate the concentration, the natural log of concentration, and 1 over the concentration. In order to get the concentration, you use Beer's law. So previously you determined this extinction coefficient. I'm making up numbers, but let's imagine that the extinction coefficient was 30,000. In order to calculate a concentration in molarity units, I'm going to take this absorbance and divide it by the extinction coefficient. In other words, equals this number divided by 30,000. Again, your extinction coefficient might be different. This is a made-up value, so you'll want to use the number that you actually calculated. You hit enter, and there you can see a concentration value in molar units. I want to calculate this for all of them. So I'm going to double click on the right, and you can see that it will propagate that formula the whole way through. Okay. That was step number, I don't know, 2 or 3. The next thing I need to calculate is the natural log of the concentration. You know, Excel made a copyright symbol. I hate when it does that. There we go. Natural log is a mathematical function in Excel. So the code to do it is to type equals. Anytime you want Excel to calculate something, you start with an equals. And the specific code is natural log. If you type in ln, you can see that this little hint is telling me that it will return the natural log of a number. ln, I'm going to do a parentheses and then click the cell that I want. Back parentheses, enter. And there I get the natural log of that one. I can go to the lower right, double click, and I get the formula for all of the values. Last but not least, I wanted to calculate 1 over the concentration. Again, this is a mathematical formula. So I'm going to start with equals in Excel, and all I'm going to do is take 1 divided by concentration. Hit enter. Here we go. Propagate the formula, and there I go. Now, what I need to generate are 3 plots. 1 corresponding to the concentration, 1 corresponding to the natural log, and 1 corresponding to 1 over the concentration. And you'll need to do this for each trial, so there'll be a total of 9 plots. Let me show you a shortcut. The first one will be concentration versus time. I showed you previously how you could just move data sets. And so rather than plotting absorbance, if I want to plot this concentration, I can simply move this data set over here. And I have now plotted the concentration versus time. You can do some things like make this number look nice. I can format the axis. Axis options, it's here. Number. I'm going to change it to scientific notation, but there we go. Rather than making a whole new plot, here's my advice. Close this. Copy and paste this plot. So I have just hit Control C. I've copied this plot. I'm going to click into another cell, so I'm off of the plot, and then hit Control V, paste. I've just pasted it. So now I have 2 copies of this plot. I'm simply going to move over this data set to the natural log, right? So again, I've clicked on it. It's telling me it's plotting time versus concentration. If I go to the edge of this colored cell, I get the cross. I can click, hold, and drag. And I now have plotted the natural log versus time. Second one. Sorry, second. This is the third one. The third one is 1 over concentration, so it's the same game. Okay. I can click the data set. I go to this colored cell, click and drag it 1 to the right, and there we go. Those are the 3 plots that you have to make. You need to make them look pretty, put chart titles on them, put axes on them, units, all of that kind of stuff. But there's one other thing that you need to do, which is relevant for this lab, and that is add a trend line. I'll show you how to do that really quick. Okay. If I pick a cell, or sorry, a chart, in the version of Excel that I'm using, I get a little plus sign over here. Okay, so I can add chart elements, again, titles. And in this case, what I'm really interested in is a trend line. So if I click this trend line cell, it has added a trend line. Now I can't see this, and I can't see it because the trend line is right on top of this data set. So I'm going to have to go back in and zoom in to look at it. I am going to right click so I can adjust this axis. I go to Format Axis. I want the new maximum here not to be 0, but negative 1.0 times 10 to the first. That's negative 10. Okay. This will zoom in. And I can just barely see on this plot this dashed line. Okay. That is my trend line. If I click it, I will hopefully get some options to format the trend line. If those don't pop up, I would right click and go to Format Trend Line. And what you'll see are a bunch of choices. So you can pick the type of fit, a linear, polynomial, whatever you want. The one that you're interested in is displaying this equation on the chart. Okay. So there's the equation of that line. Negative 0.0036 minus 11.22. Right. You can do the same thing for your other plots. This was the 1 over concentration. So if I click on it, I'm going to click this cell or the plus sign. I'm going to add a trend line. And here you can see very clearly the trend line. Right? You can format it. You can add an equation. Away you go. Now, move. It will turn out that Excel will fit any data set to a straight line. So just because it has returned an equation of best fit does not mean that it is in fact the best fit. And one of the things that you're going to have to do in this lab is look at the quality of the fit and assess which one looks more straight. Okay. From the linear plot, if it's natural log, if it's concentration, if it's 1 over concentration, you can determine the order of reaction. Review the pre-lab notes if that's not clear to you how to do that. And once you identify the linear plot, remember that the rate constant is equal to the negative slope. Slopes often have units, so make sure you account for that. That is how you will extract the rate constants in this data analysis. Hope all this helps. If you have questions, please let me know. Good luck. It's a fun lab, and Excel is a great tool that you will use throughout your life, no matter what you do.